In this video, we'll learn how to use LTSpice to analyze a simple circuit. Let's say we want to analyze this circuit and find out what I and VAB are. So the first thing we need to do is recreate this circuit schematic in LTSpice. So have LTSpice open and click on New Schematic. Now we need to add components. Let's first add our voltage sources. We have 3 voltage sources. So we're going to click on this Add Component or Component button. And in the window here, we'll type voltage to look for the voltage component. Let's say we had a current source. We could type in the word current and get a current source. But since we have a voltage source, we have voltage. And I'll click OK. So now I have a voltage source that I can move my mouse around and place wherever I want in the circuit. When I'm ready to place it, I will just click down. And then I could place another one. I can rotate by using Control R. Notice I'm rotating the source any which way I'd like. So I'll put my other one here and then my last one over here. When I'm done with the component, I can click Escape and it will get rid of the component. Now I'd like to add 2 resistors. So notice I have a resistor up here. Once again, I can rotate using Control R and then place it down wherever I'd like. I have 2 resistors, so I'll put them here and there. When I'm done, I hit Escape. And now I just need to connect everything. So I'll click on the Wire tool and I just go around clicking where I want to make connections. So I click. I want to make a turn here, so click, connect, click, click, click. So I'm just clicking everywhere I'm making a connection or making a turn. And there we have it. Then hit Escape when you're done. If you made a mistake, say you made a bad connection, here maybe I had this extra wire sticking up over here that I didn't want, I could click Delete, the Delete key on the keyboard, and the scissors will come up and I can cut out whatever element I want to delete. I can also move components. I'm hitting Escape because I'm done with deleting. There's this Move tool that I can click on a component and move it. I can also use the Move tool and highlight a bunch of components and move them together. Whenever I'm done with a command, I just hit Escape. Now, one thing we are missing from this circuit, even though it is not explicit in our original drawing, is I need to tell LTSpice where the ground is. It has to have a reference. So I hit the ground symbol, or you can hit the letter G on the keyboard and you'll come up with your little ground symbol and place it where you'd like ground to be. And hit Escape. Now we're ready to give the circuit values, so I will right click on the element, and this has a value of 30 volts. So 30. This one has a value of 3 ohms, 10 volts, 5 ohms, and 8 volts. Alright, my circuit is ready to be simulated. Because this is a DC circuit, it doesn't really matter how much time I simulate it for, because it's going to hold a steady value for the whole time. So I will just go to Simulate, Edit Simulation command, and I will run a transient analysis for just 1 second. Like I said, the time doesn't really matter for a DC circuit. It will matter more when we get to other types of analyses. Notice the command for this simulation is .tran1, which we will just plop down anywhere in the schematic to say we just want to run for 1 second. So now I can go ahead and simulate, hit the running command button, or you can hit simulate run. And here we go, we get a blank graph that shows up. So now we can pick what we'd like to see. Well, we want to know the voltage between A and B here. So whenever I tap on a node, you'll see a little probe comes up. I'm not clicking anything right now, you're just seeing that a little probe shows up. If I just click there, it's going to give me the voltage from that point to ground. I can also explicitly say I want to go from this point to ground by clicking, holding it down, and then releasing at my ground point. So notice VAB is shown in this graph. It looks like it's about 28 volts. Maybe this graph is a little hard to read, so I could change the axes. Notice there's a little ruler here. Just click, and we can change the axes to be maybe 30 volts. And how about we'll just make the ticks 1 volt, and the bottom can be 25. Let's see if this gives us a better reading. Oh, we see that it's clearly 28 volts. We can also see that value by clicking on the label for the node, and that brings up a little cursor menu. So this cursor is right now, right at this point, cursor number 1. And we see we're at almost 0.5 seconds in the analysis, and we're at 28 volts. So we can also get a readout here. And if I use my arrow keys, notice the cursor is moving, so that I'm moving it right now to the right. My time is changing, but the value is staying at 28 because it's a constant voltage. Okay, so I found out what VAB is. Let's see if I can find out what the current I is. So the current I is this current through the 8-volt source, which is the current in the whole circuit because, well, there's just one loop. They're all in series, so it's all the same current. To find out its value, I click on the element itself. So notice that I have a little red arrow going through a little loop. That's going to give me a current measurement, and I can do that on any element I choose. It's important to pay attention to the direction of the current. So notice through this 5 ohm resistor, it's going to the right, but through this 10-volt source, it's going to the left. So even though these are the same current, they're going to show opposite signs because they're defined as going opposite directions. So since I want the current going to the right, I'll just click on this element, and now you can see the current scale shows up on the right hand side. It's the current through my voltage source, and it has a value of 4 amps. So this blue line we're measuring using the current scale. If I wanted to get rid of this voltage source showing, I can just double click and it will only show the current. Again, let's check to see that the current going the opposite direction should just show -4, which it does. Here it is down here, the current through V2, because LTSpice is defining it as going left, is just shown as a -4, which makes sense because we know the current going to the right is a +4.